Frequency. Frequency means frequency of the band. Again, it is 900 megahertz. In US, when you use 900, this actually applies to both 11AH and this LoRaWAN. But when in US, there is a power limit. You cannot speak louder than this, but no duty cycle limit. And I will explain what is duty cycle. In Europe, power limit is, I think, kind of very high, but there's a duty cycle limit. Duty cycle means you cannot speak more than 1% of the time. Okay, keep quiet. You speak too much, kind of thing, so they will say. And so as long as you keep 1%, which means 100 people can speak. After that, 1%, 1%, 1%, the thing will become congested. And here, what saves in the United States is that your power is low. So if you speak here, maybe other people can speak over there, maybe other people speak here. But somebody can just occupy this area forever. So each has advantages and disadvantages, but they came up with this. Anyway, in Europe, the frequency is different. In Asia, the frequency is even different. And so basically, when you get a LoRaWAN, you have to select the right one. All right, when you go to Amazon, and I went to Amazon, you may find that most of this stuff that is being sold is European. Okay, legally, you should not be using that in the United States, but who is monitoring, right? Nobody is monitoring until somebody goes and complains that my neighbor is, is doing it, and then they will come after you. Okay, so look for 915 megahertz.
Is the 433 megahertz band available in the United States?
No. I don't know, actually. I will have to check. See, the thing is, at some point, I had put the ISM band at different places, but that slide is not in front of me, so from memory, I don't know.
I think it is. I think I looked it up.
Okay. Okay, so if it is, then you know better than I do. Yeah, so basically 433. So the thing is, 915 is where most of the activity right now is. See, what happens is, I will tell you what are the disadvantages of 433. 433 will go even farther, but then the bandwidth would be even narrower. Okay, so if they give you, I don't know how many megahertz they're giving you at 900, 433, they will give you half of that band. You can have two channels, one channel. So if given between the two, they selected 915 for the US, and wherever 915 is not there, then they go for 433. Actually, it says in Asia, but I think that's slightly incorrect, because I think if you go through different countries, Korea, China, India, they might have different number there. Not all of them are at 433. Okay, Japan. So I think they just put Asia together, but I think, if I remember correctly, Japan was at, here is the thing, let me see, where was the number? Okay, here, let me just go back to this slide. China has this 700, this 800, I don't know where 433 is, maybe 433 is not shown in this picture. But every country has a slightly different band. So to put whole Asia into one block, there's no Asian Radio Regulatory Authority. So they don't work together. I mean, like China and India don't work together on setting up a bandwidth, right? Everybody goes to UNO. So there is a United Nations, basically radio authority, which says, okay, everybody please free up 900 megahertz, and then everybody will free up 900 megahertz. So that's the only thing we have. And what they have done is, because they could not make everybody change, they have divided the world into regions. So region 1, I forget, maybe United States, region 2 is Europe, region 3 is Asia, and so on and so forth, right? So that is what is happening is, yeah, so the regions may decide together in some sense. Back to frequency, I think frequency, right? Same techniques can be used in 2.4 and 5.8. So they're not saying that you cannot use the same technique. And I haven't shown you the technique, and that is the thing which is coming up in a few slides. But you can use the same technique at other frequencies. Of course, you will not reach that far, and you will not be that clean, and so on and so forth. Now, there is still one problem with LoRaWAN. LoRaWAN has not thought about how to do multiple networks in the same area. So if you have a network, if you start experimenting with it, I can't use it, because basically you would be in a mile and I will be in a mile. We'll be just killing each other without knowing each other, right? So this is good only for public networks, they call it, like government owned. So the city of St. Louis can put a LoRaWAN, and then that's it, their network. That's how I saw this in Dubai, right? The city of Dubai had put this thing, LoRaWAN. So right now it is for public single deployment in an area. All gateways report to the same server. Any devices can talk to any gateway, but all the devices use the same frequencies. All right, so what is the secret? Secret is the sharp spread spectrum. Okay, this slide actually was there in a previous lecture. You had asked me about chirp. I think it was in 60 gigahertz, someplace we had it. I had removed it at that time. But anyway, you had asked me a question, I said, no, I removed it. So chirp, I'm bringing it back because now for this lecture, I need it. So we talked about spread spectrum techniques, DSRC, and then, we had the coding, and then we had other one, right? Frequency hopping. Now, this is another one. This is actually not frequency hopping, but it is a signal with continuously increasing or decreasing frequency. So when you send something, you start at frequency 1, and then you keep increasing frequency. So here it is shown in the time domain. This is low frequency, and then becoming higher and higher and higher and higher frequency. And this sounds like birds chirp, or whales chirp in this case. Chirp. Okay, the frequency keeps going up. Or keep going down. And therefore the power becomes spread over an area. And then basically that has certain properties which we will not go in here, but that makes it resistant to noise. And with this chirp spread spectrum, you can get farther than without it.